Lesson 7, Scatterplots. So a scatterplot is a graph with multiple points and it's not linear. And more than likely this is how our data will be given to us. Data usually doesn't come linear. It's kind of all over the place. So looking at this graph, we have hours and kilometers. So what we're going to do is let's define our independent and our dependent. So independent is x, so it's time, we'll call it t, in hours, and our dependent is our y, and it's our distance, which is in kilometers, so we will call it d. Now in our graph, you can notice that these 3 points don't really match. So what we call those is outliers. They're data that are recorded, but not really the same as everything else. So they can affect our information greatly, but when we make a best fit line, which is what we're about to do, we just want to kind of ignore that. So we're going to ignore those outliers, and what we're going to do is we're going to draw a line that goes through a majority of the points, and so it's equal on both sides. So using a straight edge, I drew my line that looked like this. I'm trying to do this as carefully as possible. And notice that my line went through the point 20, 30 and intercepted at 0, 5. So if you could make your best fit line similar to that, that would be great for this example. So what we're going to do is we're going to find our intercept and our slope. So first, to find our slope, or let's make a small table of values. So we have a point at 0 and 5, and a point at 20 and 30. Our slope is equal to y2 minus y1 over x2 minus x1, which is 30 minus 5 over 20 minus 0, which is 25 over 20, which is equal to 1.25. And our intercept is at 0 and 5, so b is equal to 5. So if we were to plug into our equation y equals mx plus b, we know our y is d for distance, our m is 1.25, our x is t, and our intercept is 5. So here is the equation for our best fit line. Using the equation for the best fit line, and also by our graph, we can estimate information. So we want to estimate the distance at 33 hours. So we're going to do it with our equation and with the graph. So I'm just going to erase this and get rid of that. So we want our time to be 33 hours. So we're going to plug in t to be 33. So d is equal to 1.25 times 33 plus 5, which is equal to 46.25. So now we're going to use, I would suggest using a ruler, and at 33 hours, which seems to be about right here, this is hard to do. It looks like it could be about 46.25, maybe a little bit off, but I am using the iPad. And for part C, we want to find 63 kilometers, so we know d is equal to 63. Let me erase this. So d is equal to 63. Let's look on our graph first this time. So 63 probably is around here. Oops. A little higher than that. So somewhere between 45 and 50. So let's plug that in. So 63 is equal to 1.25 t plus 5. So we're going to subtract 5 from both sides. So we have 58 is equal to 1.25t. Divide both sides by 1.25, and you should get 46.4, which matches pretty closely to our graph. So that is how you use Scatterplot. That is how you find the best fit line, and how you find the equation for that best fit line.